So next, I'm going to be going over Helm and Let's Encrypt. So as you saw, one application can require many YAML files just for deployment. So you saw in that one, we had a deployment YAML file, we had a service YAML file. You could also you could add two to there instantly if you used ingress, or if you use like a volume persistent. So that's 4 per application. Let's say you're working on a team across your whole organization, you have 50 applications. Just imagine how many YAML files and how much time that would take you. So this could really kind of get overwhelming and time consuming. You don't want to spend all your time doing files, copying, pasting. It's just not fun for anyone. So that's where Helm comes into place. And Helm is a Kubernetes package manager. It's not part of the Kubernetes ecosystem, like it's not built into Kubernetes. It's something that you have to add and install on top. So what is Helm? So it's a package manager that runs on top of Kubernetes. So basically what it does is instead of having to manage your individual applications or microservices, you manage the packages. And I'm going to show you everything that's in the packages, everything that we can get, and how this kind of can help with your workflow. You configure Kubernetes packages called Helm charts. So for example, if you're using WordPress for a specific application, instead of having to write all the resources that you'd need to deploy that and get that out on your Kubernetes cluster, a Helm chart has all that information for you already. Or if you're creating a Kubernetes resource that, let's say, multiple people on your team need, you can create a chart and then just share it among your team so people aren't redoing work multiple times. And then it allows developers to package and configure and deploy apps and services to cluster. So again, rather than having to kind of do those steps over and over that I just showed you, it really gives you simple commands to do this pretty easily. And then these are the kind of big 3 parts that go into Helm. So you have your chart, your config, and your release. So your chart is the biggest piece that you're going to interact with. It has all the data you need to create your Kubernetes resource. And by resource, I mean this is going to create anything that you need for that specific container. So that's going to have your deployments, your services, volume persistence, anything like that. It's going to have all that information in there already, and it's going to have those YAML files ready. And then you have your configuration. So this is the default values that you're going to use for your specific chart. So this can be like replica sets. If you need a username and password for a specific chart that you're using, that's where you can set it up there. So basically this means that you could just have all the values in one place, and then you can use it in multiple different charts and areas that you need to. And then you have your release. So the chart and the config together then create a running instance of your Kubernetes resource. So you've created the chart locally, you've created the config locally. Basically, once you do like Helm install, it'll take both of those things, combine it, and then it creates a release. And Helm is split up between the Helm client and the Helm server, or the tiller. So the Helm client is the CLI client that you're going to deal with. So that's where you would run Helm install, Helm upgrade, anything like that. Any of the Helm commands, this is going to come from the Helm client. This is what interacts with your server to apply the changes that you want to your cluster. So the big thing about Helm is that life cycle of your chart. So when you first install it, you're going to have your first release, and then if you upgrade it, that's going to be any changes you have to your chart, and you can also roll back, anything like that. So those are kind of going to be the big commands that you're going to run. Chart development. So basically what this means is anytime you want to develop a chart, this is where you're going to do it on the CLI. There's also a public workspace, I think it's called Helm Workspace, and that has all of the public charts that you can kind of just pull down and use, and this is all managed within that CLI tool. And then you have your tiller, or the Helm server, and this sits between your Helm client and your Kubernetes API server. So your Helm client, you're going to run some sort of command, it's going to go to your server, and then your server is going to take that command and go to the Kubernetes API server and say, this is what I want to do, make these changes on my Kubernetes cluster. And then this is what combines the chart and the configuration to build a release. So once you have that chart and you've set up the configuration, it's what's going to take those two, put it together, and then build that release and get it up and running on your cluster. And this is what tracks the releases and the installation. So again, you're going to have V1 on your installation, but then you're probably going to have like V2, V3, any of your releases, this is where it's going to be tracked. And then it handles the life cycle of the charts in Kubernetes. So if you want to delete a chart, this is what's going to go in and tell the Kubernetes API server, hey, I want to delete this, hey, I want to install this. Any of those actions, this is what's going to handle it. So now I'm going to show you what a typical chart looks like. So you would have your package name, and if you guys just want to look at stable public ones, you guys can just go on Google. There's one for WordPress of there, Ingress, like anything you kind of think of. But this is the usual structure of that package. So, and specifically I'm going to go over the charts folder, the templates folder, and the YAML files. Again, more YAML files. So this is the chart.yaml file. This is just going to have all your metadata for the chart that you need. So if you're publishing this chart, you know, globally, just out there, you're going to want your users to know all this information about it. And then you're going to have your requirements.yaml file. This is where you're going to set up your configuration. So this is where you're going to kind of hard code those values that you need. If you have to set up like a username or password for a specific subchart you need to use, this is where you're going to do it. Actually, this is not where you're going to do it. That's the next slide. This is actually where your subcharts are going to be. So you would have, so if you're using subcharts, so for example, WordPress, you're going to need to use a database. This is where you would specify your subchart. So because WordPress is dependent on this other subchart, you're going to have it in this requirements.yaml file. And then you just need your name, your version, and the repository. Another thing you can do if you kind of want to make changes and updates to your subchart, you can put it in the chart folder, and that's where you can manually insert any charts that you need and just have it there. I think this is the easiest way when you're first getting started, just because it's like really simple. And this is the values file that I was talking about in the last slide. So this is where you're going to put all your configuration values. So here you can see I tried to make this similar to what the configuration was in the previous service.yaml file. So here you can see the replica count. So in this case, I want 2. The type node port. So here, probably in a Helm chart, you don't want to use node port. I wouldn't advise this. I just wanted to show you kind of similarities between this and what I kind of showed you before. And then your image repository. And then the templates. So this is where you're going to be pulling in that configuration and that subchart information. This is what's going to go through, and it's going to give you all the definitions you need for your deployments, your services. This is where, when you were creating those YAML files before, this is where all of that's going to live. So here you can see this is a service.yaml file comparison. So you saw before how we just created it just for, you know, a regular Kubernetes application. It's very similar with Helm as well, if you kind of want to have the same configuration. But here you can see that we're pulling values out of those other configuration files, and you don't have to hard code it. So if you have a lot of YAML files, you don't have to hard code these every time. You can just pull it from your configuration. And then this gets really nice when you have multiple of these files. You're using a lot of subcharts, anything like that. And then the commands for this. So a lot of it's pretty easy. So you use Helm create and then whatever your chart name is. So even if it's a public chart that you're using, if you want to work with it locally or within your cluster, you still have to create it here. And then that's going to basically create like your version 1. Helm install chart name. This is where you're going to do all your deployments. It's basically going to go through that templates folder, and it's going to generate all of those resources in your Kubernetes cluster. And then the last couple ones, Helm list, so you can see all your deployed releases. Helm delete if you want to uninstall a specific release, and then Helm upgrade and rollback. So if you want to, again, do upgrades or rollbacks. So next, I'm going to be going over Let's Encrypt. How many people have worked with Let's Encrypt or have heard of Let's Encrypt? Okay, it's a good amount of people. Okay, so basically Let's Encrypt is a certificate authority. So in this kind of little phase, I'm going to be going over more high level the process. If you guys want to learn more how to actually implement it, I have links for that. But just for time's sake, I'm just going to kind of go over how that interaction works. So what is Let's Encrypt? So it's a certificate authority that issues a certificate in order to enable a website to have HTTPS. So I'm sure you've seen a website that says this website is not secure. Are you sure you want to go there? That's because they don't have HTTPS enabled. So basically what a certificate authority does is it signs a certificate and encrypts it, and then so it vouches for the authenticity of a particular website. For the certificate authority to issue the certificate, a web server is required to demonstrate control over their domain. And then this uses the Acme protocol. So basically with the Acme protocol, along with Let's Encrypt, it allows us to automate this basically certificate issuance, so no one has to go and manually do it every time. So first, we need to have the web server prove control over the domain. And how this is done is basically Let's Encrypt will send it one or more challenges, which I'll go over the next slide, some examples of that, and then it'll basically give it something and say, hey, I need you to sign this with your private key when you're finished with completing those challenges. And these are some examples of challenges that it could do. So provision a DNS record under a domain, provision an HTTP resource under a URI on a domain. I'm going to be going over a specific example where the challenge is it'll tell the web server put this specific file at this path name, and then how Let's Encrypt kind of goes in and make sure that that's what's happening. Right now, these two are the only supported methods of Let's Encrypt, so only HTTP and DNS challenges. I haven't worked with other certificate authorities, so they could have different challenges, but for Let's Encrypt, these are the two main ones. So this would be an example of a challenge issued. So let's say the web server says, hey, this is my domain, example.com. Let's Encrypt is going to say, okay, put this file at the end of this path name, and then I'm going to go check that this challenge has been completed, and also sign this with your private key. So the web server completes that challenge, and it also signs that nonce with that private key. So Let's Encrypt then verifies that signature and that challenge success. So if it wanted a file at a particular location, it'll go in and try and download that file, make sure it has the expected contents, and if it does, then it will issue a key pair value back to the web server, and that will be the authorized key pair values for, if you want to renew it or revoke it, anything like that. And then again, Let's Encrypt signs and returns the certificate. So this is it's a little bit confusing when you first look at it. But here you can see, and this is after the first diagram I showed you, Let's Encrypt puts that file at the end of the file name, and then it'll go back to Let's Encrypt. Let's Encrypt says, okay, that's good. And then also at the same time, the web server has signed that nonce with the private key, and now it has the authorized private key. The authorized key value pair is important because that's what it's going to use for if it needs to renew a certificate or revoke a certificate, which I'm not going to go over in this talk, but on this website down below, I know it's kind of small, it'll be in my resources. If you guys want to learn more about that method and that life cycle, you can go there. And then at that point, the web server should have the certificate, and it should be able to enable HTTPS. From a user perspective, it's secure, everyone's happy, so it's victory. And that's the end of Helm and Let's Encrypt version. Next, I'm going to be going over Istio, more high level.